In question 10, we have an entomologist maintaining a population of grasshoppers. They grow by a factor of 1.2 each month, and 30 are removed. So this is a different equation question. UN, we have U0, we want U1 and U2, and we're going to solve this. So to find U1, we'd have to take U0, multiply it by 1.2, and take away 30. So this will be 175 with a growth of 20%, minus 30 would be a growth of 35. 210 minus 30 is 180. U2 would be U1 by 1.2 minus 30, which is 180 by 1.2 minus 30. So the growth is 6. 36 minus 30 will be 186. And from this, we should be able to see that UN plus 1. 1 goes down 1, 2 goes down 1 is equal to UN times 1.2 minus 30. So if we set up our difference equation in terms of UN plus 1 and UN, U2 is equal to 1.2 times U1, and if we write U1 as U0 by 1.2 minus 30, that's 1.2 U2, just this part. Don't forget about the other 30. So we're going to set it up in terms of 1.2 UN and then my geometric sequence. So U2 in this case would be equal to 1.2 squared times U0 minus 1.2 by 30 minus 30, and this is the difference equation, 1.2 to the power of n times U0 minus outside the bracket, and if we reverse the sequence starting with 30, we'll have 30 plus 1.2 by 30 in this case, and this will keep getting extended out into 1.2 to the power 2 will be next, and then 1.2 to the power 3 all times 30. So we have a geometric sequence where a is equal to 30 and my ratio is equal to 1.2. So we sub this into my formula, a times 1 minus r to the power of n over 1 minus r. We get 30 times, now we can keep it in this order or we can reverse it around. We're going to get 1 minus 1.2, so let's reverse it around and say 1.2 to the power of n minus 1 over 1.2 minus 1, and we see this fifth on the bottom. 0.2 is 1 over 5, so it's going to be 30 divided by 5, which is 150 times 1.2 to the power of n, and then it will be 150 by minus 1, minus 150, and we're bringing down this minus sign that's outside, and the 1.2 to the power of n times U0, and we'll end up with 1.2 U0 minus 150, 1.2 to the power of n, then plus 150. U0 is 175, so we're going to get 175 times 1.2 to the power of n minus the 150 times 1.2 to the power of n plus 150. So the difference equation combining these two becomes 25 times 1.2 to the power of n plus 150, which is the answers to part 2 and part 3. Part 4 asks us to find U12. So let's stick that back into my difference equation. 25 times 1.2 to the power of 12 plus 150 And that gives 373 rounded. So that's the end of this question. Part B, we have circular motion. So we have a toy car going onto a loop in this direction. We have its initial speed. Or is the radius from here to here and from here to here. We need the height of this, so we're going to need to get this height here. So straight away we can say that this side in here is going to be or cos is adjacent to it, or cos theta. That will help. We're told the model ignores friction and draw a diagram to show the forces acting on the car. So if the car is, let's say, at this point, there's a force of reaction between it and the road. We've got its weight coming down, which is mg. We have theta. So the forces maybe we do as well. The angle is theta with the vertical, making the one inside here theta. So if we make mg the right angle, the force here will be mg cos theta. And we also have the reactionary force. So we have mg cos theta, and or will be equal to the centripetal force directed toward the center, either m omega squared or mv squared over r. And in this case, I think we're using mv squared over r. No mention of omega. So, because if the car loses contact, I've read the second part, it means that the reaction is equal to 0. Obviously the car is going to keep moving, there'll be speed, but or it's going to be equal to 0, so we do need things in terms of or here. So the forces, if we get it down into v squared, which we will need, is going to be or mg cos theta plus or times or, which will be equal to 0 in this question, is equal to mv squared. So if it loses contact and or is 0, we're going to get dividing by m, v squared is equal to just or small or g cos theta. So we have conservation of energy here. We have potential energy and kinetic energy at A. So at A, mgh is equal to 0. We have a half mv squared. My potential and kinetic energy. So a half mv squared is a half m by u squared or v squared, but could write u maybe for the initial, and that's going to be just kg or at B we have a half mv squared. Well, I'll do mgh first. It's here mg by h, which is this radius, plus the r cos theta that we got earlier, so mg times or plus or cos theta plus a half mv squared. We have v squared in terms of or g cos theta. So if we simplify this, we're going to get mg or plus mg or cos theta plus a half m by v squared, which is or g cos theta. That's the energy at position B. Will have to be equal to the energy at position A, which is just a half m k or g. So we have m or g, so we're going to divide by m or g to get 1 plus cos theta plus a half cos theta is equal to a half, it's just going to be k over 2, just half a k, multiplying by 2, 2 plus 2 cos theta plus cos theta is equal to k. So we're going to get k minus 2 is equal to 3 cos theta. So cos theta is equal to k minus 2 over 3, which is what they were looking for in part 2. Part 3, we have to find the minimum value of k such that the car successfully completes the loop without losing contact. What's going on there? But it successfully completes the loop without losing contact. It means that the car is here. Well, theta is going to get smaller. It's going to get bigger. Then it's going to become 0 degrees. So the cos of theta will be the cos of 0 degrees, which is equal to 1. So let's simplify down for us. 1 is equal to k minus 2 over 3. 3 is equal to k minus 2. So k will be equal to 5. So the minimum value for k will be 5. So k must be greater than 5 for this to successfully complete one loop.